So we will now start with non-parametric tests. One test is there which we have to study, which is chi-square test. Now basics. So what is the use of chi-square test? So whenever you are given proportions, number of individuals or any qualitative data, and you are asked to compare it or test whether they are independent or not, or is there any association between these two variables, you will use chi-square test. How to identify a question is from chi-square test or not, we will discuss later. So for formula, there are three formulas. One is for test statistic, which is chi-square. This is for expected value, where row total and column total, and n is grand total. And degrees of freedom, we will see all of this while we solve the problem. Now one more thing is, there is chi-square table that you will have to make. So there will be two variables given, a and b. There will be another two variables based on the condition. Now this can be more than two, but for most of the problems that you will see, there will be 2 by 2 table. It is called contingency table. 2 by 2 contingency table. So let's say our value is a, c, b and d. We will calculate this based on the formula above this. And there is total. This is called row total. Both of these are called row total, and both of these are called column total. So let's say you have to calculate the expected value of this one. You will use row total into column total. So for this, row total will be this and column total will be this. So it is a plus c, this a plus c and a plus b upon this is grand total. This is grand total. Okay. Next we will discuss a problem. So find whether the drug was efficacious or not by applying the chi-square test in data given below. Now a drug will be efficacious if it prevented the death. So in control group there were 10 people who died and 25 people who survived. And in experimental group, which was given the drug, 5 people died and 60 survived. Now we will have to find whether there was any association between people who were given drug and their survival and death. So for this kind of arrangement, you can basically ask a question: how many died or survived, or how much died or survived. How many died or survived makes more sense. So it is a non-parametric test and not a parametric. So we will use chi-square test. Okay. There is one precondition that you have to remember. Any of the individual value should not be less than 5. They can be 5, but if they are less than 5, then you will have to use different kind of non-parametric test. Chi-square test is inapplicable in those cases. Most of the time you will only get the situation where the individual values are more than 5. Now step 1. So step 1 is null hypothesis. Null hypothesis will be like different from all other tests because there is no notation that is being used here. So H0 will be what we have to find out in question, whether drug was efficacious or not. So H0 will be drug was not efficacious, and H1 would be drug was efficacious. Okay. Now this is the most important part, which is calculation of chi-square, which is test statistic. Now this much information we are given. So we will first calculate the total value. So here the row total will be 35, here the row total will be 65, column total here will be 15, column total here will be 85. Now expected value, we have seen the formula, this formula, where RT is row total. So what is row total here? So row total for this control and died is 35, and column total for the same would be this 15. So the calculation will be 35 into 15, and here total will be 100, grand total. It is called GT, grand total, upon 100. We will calculate this and we will get 5.25. Same way we can calculate this one, for this one it will be row total 65, column total 15. So another would be, this is for E1, for E2, 65 into 15 by 100, it will be around 9.75. So 9.75. Now you can either use this formula for this one, or there is another method that is, you can subtract this value from this value. Okay, so it will be around 29.75, and same way this value will be 55.25. we have subtracted this value from this one, that's why this value was obtained. Now after getting all these four values of expected values, we will make another table to calculate chi-square value. So chi-square value, we will use these 5 things: the all observations, all expected values, O minus E square, and this is O minus E square upon E. E is expected value. So we have written in this order: first this, then this, then this, and this. Okay, 10, 5, 25, 60, and respective E values. Now O minus E would be 4.75 positive. This will be negative 4.75. This will be negative 4.75 and positive 4.75. Square of all this value is similar. That is 22.5625. Now we will divide it by their respective E values. So this will be divided by 5.25, this will be divided by 9.75, and respectively. So here we will get 4.3, here 2.3, 0.76, and 0.41, and the total will be 7.77. So chi-square value, which is this value only, is 7.77. This is the basic. Now we will compare it with tabloid value. Now for this particular chi-square test, we will learn how to calculate tabloid value. So tabloid value is nothing but chi-square of with x dimension being alpha and y dimension being degree of freedom. Alpha is given as 0.05. Degrees of freedom can be calculated as column minus 1, row minus 1. There are 2 columns and there are 2 rows, so it will be 1. See, this is 1 column, this is another column. Same way, this is 1 row, this is another row. There are 2 rows and 2 columns. So we will have to calculate chi-square for 0.05 and 1. How we will calculate it? So this is 0.05 and this is 1. The value that is in common is 3.84. This is a very important value, as in most of the cases you will have same scenario where you will be given 2 by 2 table with n or degrees of freedom being 1, and significance level most of the time will be 0.05. So remember this value, it will be helpful. So our x calculated was 7.77, which is actually higher than 3.84. So we can say that it is higher, and it is a significant result. Okay, so whenever calculated value is higher than tabloid value, the result will be significant. So in conclusion, H0 has to be rejected, and we will conclude with alternative hypothesis being right, that the drug actually was efficacious. So for a practice problem, in ophthalmology OPD, 170 person above 40 years of age were identified, out of which 40 had both trachoma and corneal degeneration and 34 had none. So trachoma and corneal degeneration. And total cases of corneal degeneration were 101. Now find out whether there is any association between trachoma or corneal degeneration. So we have two problems, two variables, that is trachoma and corneal degeneration. Some people had trachoma, some people didn't. So T positive means they people who had trachoma, and T negative means people who did not have trachoma. Same for corneal degeneration here. So we are given that 40 had both. So this is for both, right? So 40 had both. Let me use red color. 40 had both out of 170. We are given 170, which is grand total, obviously, right? And 34 had none, which means they were both negative. They were both negative. So it is 34. Now we are given that total cases of corneal degeneration were 101. So this will be total cases of corneal degeneration, right? It was 101. Rest we can find out by simple subtractions and additions. So out of 101, 40 were both positive, so remaining will be 50, 61. Total of this will be, both of this will be 90 and 95. Now out of 170, 95 can be subtracted and we will get 75. Here we will get 35 and remaining here we will get 69. And chi-square test can now be done on this table, which is the practice problem, the answer of which will be in description. Thank you.